Okay, so starting chapter 6 today. Chapter 6 is titled Fractions. But I'll tell you guys now, good or bad, these are not the kind of fractions that you guys are used to dealing with. Okay, it's not going to be just the plain numerical fractions that you guys have loved ever since day one. These are going to be different type of fractions. These are going to be algebraic fractions. Okay, and 6.1 is going to be all about simplifying fractions. Once again, not the normal kind of fractions that you guys are used to dealing with. Once again, algebraic fractions, which is so much more fun than regular fractions, just to let you know. So we're going to write down a couple of steps first, and these steps are important in the steps themselves, but they are also important as the order that I put them in, okay? And you guys will see why once we get into some examples. So if I want to simplify algebraic fractions, already kind of warned you guys, the first thing we're going to do is we are going to factor the numerator and denominator. Now, sometimes this is going to be really easy. Sometimes all you'll have to do is factor out the greatest common factor. Sometimes it's going to be a little more difficult. You're going to have to do a little bit of work. And then other times, it's already going to be factored for you. You don't have to factor it at all. But the first thing we have to do is make sure the numerator and denominator are factored completely. Okay? The second step, think about this. We did this last chapter, and we noticed that we had some variables in the denominator, and that caused problems. Why? We had to state restrictions, right? Because sometimes a certain value of my variable would make the denominator 0, and that was really important because my denominator can't be 0. So after it's factored, we're going to look at the denominator, and we're going to state any restrictions. And it's very important that you do it in this order, okay? If you don't factor it at first, if you maybe try to do the restrictions first, not necessarily wrong, but you must state any restrictions before going on to step 3, okay? Because step 3 is where you're going to actually simplify the denominator, or simplify the fraction, and you're going to do this by canceling out any common factors. And one thing I want to mention about canceling out the common factors is you have to be really careful. We saw just a little bit of this last chapter, and I think looking at your test, most people have kind of got over this. But a 1 over x and an x minus 1, those x's don't cancel out, right? If you're going to cancel something out, it has to match exactly. So we're going to go ahead and write that down. It must match exactly, and underline exactly like 3 times. And what I mean by that, if you're going to try to cancel out an x minus 1, the only thing that can cancel out an x minus 1 is an x minus 1. The only thing that can cancel out an x plus 2 is an x plus 2. The only thing that can cancel out an x is what? An x, and just an x. Okay? Has to match exactly. Okay? So, kind of like always, whenever we write down steps, doesn't make a whole lot of sense until we get into some examples. So, let's jump into those. So, your directions today will say simplify, and then they're also going to say state any restrictions. Okay? So, our first one here, say we have 2t plus 6 over 5t plus 15. Okay, once again, I told you the steps are important, but the order that the steps are in are almost more important. So the first thing I'm supposed to do is factor. So looking at my numerator first, 2t plus 6. What's the first thing we check for in factoring? Greatest common factor. Do 2t and 6 have anything in common? What do they have in common?
3.
A 2, right? A 2 in common. I can factor out a 2. I'm left with t plus 3. Can I factor that anymore? Nope, that's factored completely. So move on to the denominator, 5t plus 15. What can I factor out of both of those? of 5. What am I left with? T plus 3. Okay, now, I know you guys are really tempted to go ahead and start canceling things out, but we're not going to do that. Remember I said the order of the steps? I've said it like 4 times already. The order of the steps is really important. You have to state any restrictions before you cancel things out, and I'll show you why. So, we're supposed to look at our restrictions. So if I look at my denominator, I'm looking for any case, any value of t that would make it 0. So you're going to look at how many factors you have. So I have 2 factors, right? I have 5 times t plus 3. Okay, so if we look at the 5 first, will 5 ever be 0? No. So we don't have to worry about the 5. So if I look at the t plus 3, what value of t would make that 0? James? Negative 3. So this tells me that my restrictions for this particular problem, t cannot be a negative 3. Because if t is negative 3, my whole denominator is 0, and that can't happen. Okay? So wherever you're going to write your answer, I would probably just write that. Anything else? Is there any other value of t that would make the denominator 0? Okay? So ready to move on to step 3 that says cancel out any common factors. Is there any factor that matches exactly? Okay, the t plus 3, right? So I can divide those out. What am I left with? 2 over 5. The reason why I said the steps are really important is if you wait till the very end to state your restrictions, does this have any restrictions? No. So you have to state your restrictions before you cancel out any common factors. Okay, make sense? So your full answer would be 2 over 5, and t cannot be equal to negative 3. Okay? All right, number 2. Number 2 says 5p minus 5q over 5p plus 5q. Okay, first thing, we are supposed to factor. Can you factor the numerator or denominator? Yeah, and factor both of them. How would you factor the numerator? Factor out of 5, and I'm left with p minus q. What about the denominator? 5. Same way, factor out of 5, but this time we're left with p plus q. Okay, now remember, before we cancel anything out, we need to look at our restrictions. Once again, just like the last one, I have 2 factors to look at, but that 5 is never going to be 0, so I don't have to worry about that. So, just something to go off of. Somebody give me something to go off of. What would make this part 0?
If they were opposites.
That is excellent. That's excellent. So let's talk about how we got there. So I know that p plus q can't be 0, right? Okay, because if p plus q is 0, the entire denominator is 0. So if I say p plus q can't be 0, I want to say more explicitly what p and q cannot be, because this is not specific enough. Now Tara says that they can't be opposites. How did you get that?
If they're opposites, then like negative 3 plus 3 would be 0.
Very good. What happens when you add opposites? They cancel out. Okay, now if that just doesn't jump out at you right away, what we've done before is we've set whatever that is equal to 0, right? Okay, and we've solved for the variable, but I have 2 variables, so instead let's solve for one of them. So if I solve for p and I subtract q from both sides, this tells me that p equals negative q. Or we could think about it, p equals the opposite of q. So what this tells me is that when my denominator is 0, my variables are the opposite of each other. So your restriction would be p cannot equal negative q, or p cannot equal the opposite of q. Because anytime they're opposites, that denominator would be 0. Okay, does that part make sense? Yes? Okay, now we're ready to go cancel some things out. What do the numerator and denominator have in common? Anything else? No, because it doesn't match exactly, right? That p minus q and the p plus q, they're really close, but they don't match exactly, so I cannot cancel them out, okay? So you'd have p minus q over p plus q, and p cannot equal the opposite of q. Yes?
Can't you cancel out the p?
You cannot. You cannot cancel out the p's, because the only thing that would cancel out this p minus q is a p minus q. You can only cancel out quantities, okay? And if you want to see an example as to why not, let's look at let's say I had 2 plus 4 plus 6 over 2 plus 6. Because what you are kind of getting at, and it's a common thing, so I'm glad we're kind of talking about this. What if you want to cancel out things that are just numbers that match? Okay, well I could cancel out the 2 and the 6, right? Going by that theory, and I'm left with 4. But is that the same thing as actually taking 2 plus 4 plus 6 over 2 plus 6? Well, 2 plus 4 plus 6 is 12. 2 plus 6 is 8. Is 12 over 8 the same thing as 4? No, so you cannot do that because it's not multiplication, right? The only thing that cancels out is things that are being multiplied, factors. Does that make sense? It's a good question. Yes?
What if, like, when you're factoring, you factor from the top of a 5 and from the bottom a negative 5. So it would be, at the top it would be 5 into p minus over negative 5 into p minus q.
So if the only difference was that maybe I had a negative sign here, that would be okay. Your answer would just say you would have a negative 1 somewhere or a negative sign somewhere. That's a good question too. Any others? All right. I'm going to give you guys, oh no, we'll do one more together and then I'm going to give you 2 to try on your own. Okay, number 3. Let's try x squared minus 9 over 2x plus 1 times 3 plus x. X squared minus 9 over 2x plus 1 times 3 plus x. First thing, I'm supposed to factor. Can I factor that numerator? How do you factor 2 terms? Do you have something squared minus something squared? And in this case, I do. I have an x squared and I have a 3 squared. What do you do with the x and the 3? Add them and subtract them. X plus 3, x minus 3. What about the denominator? Can that be factored? Or is it already factored? It's already factored. So it's 2x plus 1 times 3 plus x. Before you start canceling things out, we need to look at our restrictions. So keep in mind, I have 2 things now. I might have 2 restrictions here. Whatever this is, this can't be 0. Whatever this is, this can't be 0. Okay? So this one we have to do a little bit of work, but this one, hopefully the second one's a little bit easier. If 3 plus x is 0, what would x have to be? Negative 3. So that tells me that x cannot be negative 3. And we talked about this back in chapter 7. If you're not sure, if a number just doesn't pop out in your mind, but you're pretty sure there's a restriction, such as if 2x plus 1, set it equal to 0, because that's what I'm looking for. What would x have to be when 2x plus 1 is 0, and then solve for x? So we would get, if that is 0, x would have to be negative 1/2, which tells me x can't be negative 1/2. Okay, once we have our restrictions, then we're ready to cancel things out. Does anything match exactly? Does it match exactly? Well, no, not really, because I have an x plus 3 and a 3 plus x. Are they the same thing? Yeah, x plus 3 and 3 plus x. That's the same thing because it's addition. So those will cancel out, and you're left with x minus 3 over 2x plus 1. And don't forget your restrictions. Okay, I'm going to write 2 on the board. I want you guys to try these 2 on your own. Okay, number 4, I want you to try 2x minus 4 over x squared minus 4. And number 5, I want you to try x plus 4 times 2x plus 1 over 1 plus 2x times x minus 3. Okay, so hopefully for number 4 we got 2 over x plus 2. X cannot be 2, x cannot be negative 2 for the second one. And we have x plus 4 over x minus 3, and x cannot be 3 or negative 1/2. Any questions over either one of those? Okay, we're going to do the last 2 together because they're just a little bit different. Okay, number 6. Number 6. If I have a squared, b squared over a squared b minus AB squared. A lot of A's and B's and squareds. Okay, first thing, can I factor my numerator? How would you factor that? How many terms do I have, first of all? 1. Did we ever factor one term? No, why not? Because you can't, right? You can't factor one term. If it's just one term, that's what it is. Okay, so if it's one term, that should be your hint that you can't factor it. I know some of you are probably thinking, we could do a plus b, a minus b. But that would be if it's a squared minus b squared, right? Okay, so this just stays an a squared, b squared. You can't factor it. It's just going to stay the same. If it's one term, can't do anything with that. Okay, what about the denominator? Can I factor that? What can you do with that? We can factor out the greatest common factor. I can factor out an AB. I'm left with A minus B. Okay, before you start canceling things out, looking at my restrictions this time, how many factors do I have to consider in my denominator? How many? Don't I have 3? Right? I have A times B times A minus B. There's 3 things that you have to consider. 3 things that if they equal 0 would make the whole denominator 0. So for this first one, what value of A would make the denominator 0 for A? 0, right? If A is 0, the whole denominator is 0. What about the B? 0, right? And then the A minus B, this is what we talked about back in example 2. So far, we have A cannot equal 0. B cannot equal 0. And then if it doesn't jump right out at you, I know that A minus B can't be 0 either. So if A minus B is 0, that means A and B are the same thing. A equals B. They're the same number. So that tells me that A cannot equal B. So your 3 restrictions, A cannot be 0, B cannot be 0, and A cannot equal B. Okay, questions on the restrictions? Okay, now, looking to cancel things out. Remember, whenever you cancel things out, it has to match exactly. What do the numerator and denominator have in common? An A and a B, right? I can divide out an A, and I can divide out a B. Why can I not divide out the other A and the B with the A minus B? Would this be my final answer, AB over A minus B? Why can't I cancel those out? Tara?
One's multiplication and one's subtraction.
Exactly, because it's not multiplication in that denominator. Okay, so your final answer would be AB over A minus B. And your restrictions would be A cannot be 0, B cannot be 0, and A cannot equal B. Okay, last one, and this one's going to be just a little different than the other ones. This one, let's say we have 2 minus y over y squared minus 4y plus 4. 2 minus y over y squared minus 4y plus 4. First thing, can I factor the numerator? Nope, it's already factored. So it's going to stay at 2 minus y. What about the denominator? Can that be factored? Maybe? Okay, let's give it a maybe. If you give it a maybe, you can at least take it through the factor flow chart. And if you can factor it, your factor flow chart will tell you how, right? So first thing, is our greatest common factor? How many terms? Square in front, square in back? Yes! Isn't that nice and great and wonderful and awesome? We have y squared in the front. We have 2 squared in the back, but that's not enough, right? We have to check that middle term. Does 2 times y times 2 give me 4y? Yes, it does. So how do we factor these ones? Very good. Y minus 2 quantity squared. Okay, so keep in mind that this is 2 minus y times y minus 2 times y minus 2. That's what that means. Okay, so first off, restrictions. What are my restrictions for y? Right, y cannot be a positive 2. If y is 2, that means my entire denominator would be 2 and it wouldn't work. Okay, now we're ready to go cancel some things out. Does anything match exactly? No, it's kind of close. Right, I have 2 minus y, I have y minus 2. It's really close, but are those the same thing? No, because it's subtraction. But do you guys remember back in chapter 5 last semester when this happened? What did we do? Can't just flip them around. The math magic, right? You guys remember doing that? Okay. So we're going to have to use some math magic. But the math magic in this chapter is a little bit different than the math magic back in chapter 4. Because the math magic back in chapter 4, we multiplied by a -1 here. And then we multiplied by a -1 somewhere else to kind of cancel it out, right? But here's the thing. If I multiply by a -1 here, then I would have to multiply by a -1 somewhere else to kind of cancel it out. And one of the options would be in the numerator. And for this one, it's not a huge deal because it wouldn't change a whole lot. If I multiply by a -1 here and here, it would switch some things around. I would still be able to cancel some things out. But let's say I only had 1y minus 2 in the denominator. If I had 2 minus y in the numerator, y minus 2 in the denominator. If I multiply by a -1 here and a -1 here, it's going to flip both of them and it doesn't help me at all. Does everybody see that? Because it would flip both of them. So instead of multiplying by -1, we're going to take one of the factors, and I'm going to try to make something match the numerator. So I want to cancel out that 2 minus y. So let's take that first factor, that y minus 2, and what we're going to do is we are going to factor out a -1. Kind of like when you factor out the greatest common factor. We're going to factor out a -1, but keep in mind, if I were to redistribute that -1, I need a y minus 2 back, okay? So what kind of y would have to be there? Okay, a -y. What about the 2? Plus 2, okay? Keep in mind, I didn't change anything. That's still an equivalent expression. That still means y minus 2, but now I can say 2 minus y. Okay, does that make sense? Factored out a -1. So now this y minus 2 here is -1 times 2 minus y. That other y minus 2 is just going to stay a y minus 2. Now, do they have anything in common? Yeah, now they have a 2 minus y in common. Now all of my numerator canceled out. What do I have up there? A 1 over -1 times y minus 2. You could leave your answer like this, but I'll tell you in your book and in most sources that you're going to find, they'll move that -1 up to the numerator because you can move the negative from the numerator to the denominator. So the more common answer would be -1 over y minus 2, and then remember, y could not be 2. Yes?
How did you get -1 times y minus 2 instead of just y minus 2?
Because I had this -1, right? That -1 didn't go anywhere. Okay, any other questions on this one? Or any of the other ones?